Hello everyone. So now we're going to learn about this new type of shape, the pyramid. Now, a pyramid is when you take a polygon, some two-dimensional shape, and connect all the vertices to a point not on the same plane as the polygon. Remember, the plane is like a 2D surface. So this point is somewhere out in space, not on the polygon itself. That object is called a pyramid. The point in which all the vertices meet at is called the apex of the pyramid, the highest point. And the polygon is the pyramid's base. So in this pyramid right here, the base is a pentagon because it's 5 sides, and all the faces, the lateral faces, are triangles. Now, similar with prisms, we call a pyramid regular if all the sides of the base are the same. And a pyramid is right if the apex is directly above the center of the base, such that when you draw a line from the apex to the center of the base, it's a perpendicular line, going from the top straight to the bottom. So typically we're almost always going to work with a right pyramid. One thing to note is that we have something called the slant height, which would be AF in this diagram. Note it is not the edges like AB, AC, AD, or AE. It's from the top, the apex, to the middle of a side of the base, the center of a side of the base. That is the slant height. We call the heights AB and AC. We call those like lateral heights or the edges or lateral edges. The slant height is different. All that being said, let's continue on. The volume of a pyramid is 1/3 the product of a pyramid's height and the area of the pyramid's base. So it's just like a prism's volume, just multiply it by 1/3. We're not going to bother proving this formula because it's a pretty complicated proof, but it's very simple to apply. So let's look. ABCDE is a square right pyramid such that BC equals 6 and AC equals 5. Find the total surface area and the volume of the pyramid. Okay, so let's start by drawing our pyramid. So we have this square base. Now, if I was looking at this square from like a three-dimensional perspective, this side is probably going to be behind the pyramid, so we want to do a dashed line for that. And then we want all the vertices to meet at the apex of the pyramid, which we'll use a solid line for. And the apex will be right here, seems about right. And there we have our pyramid. Now, the way the typical naming conventions go is the first letter is the apex, so that would be A. And then we just label the base B, C, D, and E. It's a right pyramid which has a square base, where BC is 6, which means any of these sides are the same, they're all 6. Okay, but we also know that the length of AC, this lateral edge, is 5. Let's find the total surface area and the volume of the pyramid. Well, let's start with surface area. That's the area of all the faces of the pyramid. Well, the easiest one to find the area of would be the base, the square base. Since it's a square and we know the side length, we just take the side length squared. Now we need to add that with the area of each of the triangles. Now, in order to do that, we would need to find the height of the triangle. Now, in order to find the height of the triangle, let's actually draw that out. I'll do it in red. That would require us to find the slant height. Now, I'm going to draw it kind of like this. So hopefully it's a little easier to visualize in 3D space. That red line is going to be the height of that triangle, and I'll call this M. this point here, M. That's the height of that face of the triangle. I could have drawn it going straight up and down here, but I think it makes a little bit more sense seeing it in 3D space if I draw it on the side like this. Now, the slant height goes from the apex to the middle of the side of the base, which means that it's going to cut the base side in half, 3 and 3. And indeed, it's going to make a right angle because, again, it's meeting at the middle, and all the edges are the same because it's a right pyramid, which means we have a right triangle. So let's draw a triangle to represent our problem. So I'll draw it, I guess we'll just draw it in red, why not? We're going to draw the triangle because if we say that this is the right angle of the triangle, then that means that's the point M. The top of the triangle must be A. And then we can pick B or E as the other point. I'll pick B. We know that MB has a length of 3. AB has the same length as AC, so it must be 5 since it's a lateral edge. Now I want to find the slant height AM. Well, you can use Pythagorean theorem, or hopefully we can see that it's a 3 and a 5 as the side length. So by Pythagorean theorem, we should know that it's going to be a 3, 4, 5 triangle. You could just do 5 squared 25 minus 9 is 16, square root is 4, blah, blah, blah. But anyway, we get that AM, the height is 4, which means the height of the triangle on each face is 4. So in total, the area of each triangle is going to be 1/2 the base of the triangle, so multiply it by the base is going to be 6, since that's this entire length BE, times the height, which we know is 4. Now, in total, there are 4 triangles. There's ABE, EAD, DAC, and CAB. So we can take this formula for the area and multiply it by 4 to get the total number of triangles. Now, let's simplify. 6 squared is 36. Now, 4 times 1/2 is just 2. 2 times 6 is 12, times 4 is 48, which can be reduced to, well, 30 and 40 is 70, so it's 84. So our surface area is equal to 84. Perfect. Now we would like to find the volume. So how do we find the volume of this object? Well, we need the height of the pyramid. So the height would be by taking the location from the apex straight down into the center, which I will use, let's use red. Straight down to the center of the base. And I'll label this, we usually label the centers O, so why not? So straight down the center, and since it's a right pyramid, it's going to make a right angle. Now, how can we possibly find what this height is, AO? Well, let's just make another triangle out of this problem. We have the slant height, which is a good candidate, so why not just connect the center with the middle of the side as such? Now, since O is in the middle, and it goes OM, each side length is split up into 3 and 3 because it's 6, so this length has to be 3. We know what the side length of AM is, that's 4, So now we have another right triangle that we can use to solve the problem. So I'll color this one black. So let's create that right triangle. Let's do it like, make it more, seemingly more correct looking. Okay. So the right angle is formed at the point O, meeting the side length at M, all the way up at A. We know that AM is 4 from our work in this red triangle, and we know that MO has to be 3 since MO is halfway across the square. And now we just use Pythagorean theorem. So AO squared is equal to 3, well, we can 4 squared minus 3 squared, we should say, because AM is the hypotenuse. That would be 16 minus 9, which is AO squared, which gives us 7, which implies that AO is equal to the square root of 7. Now, we have the height of the pyramid, AO, square root of 7, and the formula for volume is 1/3 times the area of the base, which we know is 36, times the height of the pyramid, which we know is the square root of 7. So 1/3 times 36 is 12, and then we have square root of 7. And the area of the base just comes, the base is a square with a side length of 6, 6 squared, 36. And that completes the problem. Again, seemingly complicated problem. Break it down into basic parts, and you'll find that it's a bunch of Pythagorean theorem problems, which we have been doing since pretty much the early in our geometry career. So it's the same logic we have been using this whole time.